Hi, welcome to this Open Security Summit that is focusing on Pyroscope internals and using Pyroscope for real-time view of cloud serverless applications. A bit of a mouthful, but it's a very exciting, I think, piece of technology that these guys have been developed, and you get we have Dmitry and Ryan, who are the co-founders of a company who's driving this, and for me, this is. It's almost something I've been trying to use for ages, which is this concept of flame graphs, which I feel are a very, very good visual representation, right, of traffic and activities and processes and execution flows. And these guys are basically commoditizing a la Worldly Maps, right, the creation of it. So it allows all sorts of interesting things to occur. So first of all, over to you, just a quick intro, and then take us over what Pyroscope is.
So yeah, I'm Dmitry, co-founder at Pyroscope.
And I'm Ryan, also co-founder of Pyroscope.
Yeah, we started working on it a few months ago, and it's an open source project. We plan to make it into a business where we would charge people for hosting services and also support services and things like that. Yeah, and the idea came kind of from similar frustrations with kind of existing profiling tools, the fact that it's often kind of hard to use them. And another thing is that often you kind of want to go back in time and see what was happening with your systems in the past, but you can't really do that with the current existing profiling tools. So we thought, okay, like, why not just do profiling 24/7 in production environments, and store the data somewhere, and then have a view with flame graphs where you could kind of analyze all of this. So that's how kind of all of that worked out.
Cool. And the model, right, that you guys follow, just as a pattern, right, is very similar to the X-rays, correct? Because the AWS X-rays has also that concept of you instrument a particular part of the application, you send it to an agent, the agent grabs it and then sends it to a sort of another repository, which basically means that it really scales, right? It means that you don't introduce a huge overhead, because you don't introduce, the ability to almost process and parse and then distribute doesn't exist within the application. It's within an agent that running locally, right? And you guys have this pattern, correct?
Yeah, that's correct. So yeah, you can think of it as like sidecar pattern, right? There's a separate process that profiles the actual process where things are happening. At least that's how it works for Python and Ruby integration. For Go integration, it does live within the same process. But still, we definitely design it in a way that is very low, that it has very low overhead in terms of CPU usage, because we think this is very important if you want to profile continuously, in production environment. And that's kind of how it works. Cool. We can do a little demo.
I'm gonna say, just show
what it looks like.
When you see a flame graph, it doesn't click, right?
Yeah. So basically the idea. So this is Pyroscope. This is an example application. It does kind of things. I think what happens here is it gets a steady flow of requests, and every minute the flow kind of gets higher. It's a very simple app, but it's good for illustrating kind of the idea. So the main view, the flame graph, allows you to kind of both see from like a very high level where the time is spent in your application, and so from this you can kind of see that perhaps this compute route function, HTTP request is what takes most of the time. But then if you want to, you can also dive much deeper to really understand where potential bottlenecks are and what you need to pay attention to. And one other cool thing about this is that you can go back in time and look at this data, how it changes over time, and you can zoom in on specific time ranges and see how maybe things change. Maybe you deployed something, right, and now some other part of the code is slower. With Pyroscope, you can kind of track those changes over time, and we think that's like a
So
major.
actually, just for somebody who hasn't seen a flame graph before, right? What we're seeing here is the call tree, right?
Yeah. So
or a flame graph before, yeah.
Yeah, so the way like flame graphs work, basically this is a stack trace. So you start from the top. This is like the first function that gets called. This and that function calls this function, and that function calls that function. And the width of each bar represents how much time was spent in that particular function. And so, yeah, you can dive deeper with these and see that, these, I don't know, this function took 30% of the time, for example. And, depending on your application, that may be a good thing or a bad thing. Yeah.
So actually, how does he handle concurrent requests?
Yeah, so with concurrent requests, it will all be, it will aggregate this data, merge it together, and send it together in one kind of chunk. Yeah, we do have plans to also introduce this, basically do this kind of profiling on by request basis, so that you would be able to also look at a profile for a particular request or some sort of a job or
see, because that's I think very important, because for example, like one of the use cases that I think this would be really interesting, right, is for example, like when you're doing a security assessment, sometimes you want to see what are you hitting on the application, right? And I feel that if I was doing a security review, when I had this, right, for example, I'm starting to see how deep down I'm actually going on the application, like what am I actually invoking, right? What parts of the app I'm actually hitting. But then you need to be able to give me the view just based on specific requests, specific tokens, specific headers, right? In a way to be able to write queries where if you can have metadata that is given maybe at the host or at a particular stack trace, right? Then you can start to distinguish that. And I think that would be very powerful for this.
Yeah, that's how we're thinking about it too. We, like the way we designed the storage engine, we designed it with that in mind, that you would be able to not just select an application, but also have some sort of tagging system, metadata system, where you could select particular, I don't know, maybe controllers or hosts, things like that, so that you would be able to kind of navigate this data more precisely.
Yeah, because fundamentally what you have here is almost the flow, the execution thing, right? Like, and even if I was looking for denial of service opportunities or injections or even patterns, right? So if you think about it, like, let's say a particular SQL injection attack, right? Where actually when you have an error, right? What's interesting about this is I'm pretty sure that a SQL, for example, error will have a very different pattern than a normal flow, right? And then you go, well, hold on, what happened, right? How come normally I get the tree that you have here, but in this case, the tree completely collapsed, or it goes very, it goes back to, because you can see the exception, bubbling up, right? Because it will be it will be a very steep curve all the way up, right? And and I guess, do you have any plans for doing deltas between? I think you have already, right? You have a little bit on you can compare to flame graphs, right?
Yeah. So right now we do have right now we do have a feature for comparing flame graphs. And the next step we want to take is to be able to diff them, so that you would be able to, right now you look at two separate flame graphs, but it's kind of hard to analyze, like you have to kind of manually compare these numbers and maybe make decisions. But we want to do a diff so that the flame graphs would show you exactly where the differences are.
Also,
if I click on this, can you show me the source codes?
Not yet, but definitely, yeah, we want to do that as well. Because yeah, that's
This
another.
is where you guys need to talk to Tudor, right? And the guy from the Glamorous Toolkit. Because I feel that they, I guess, one of the challenges you're going to have, right, is that you want to make sure you stay focused, right? You want to make sure that, because you can go on so many different tangents, right? And you get people like me throwing lots of ideas, right? And you go, oh, yeah, we can go there, there, and there. But I feel that the flame graph element and the scalability is really powerful. But then if you can make this extensible, that you work with all sorts of other places and you leverage all sorts of other tools, right? So you don't have to, for example, go in and build a whole, source code mapping and visualization and graphing, right? But you allow me to ask the right question, which is, how do I actually go from here to here to here? It's that is super powerful.
Yeah, yeah, and you're right. It's hard to stay focused. We get a lot of kind of feature requests and things like that, but there's definitely been some themes, and yeah, definitely people are asking for being able to jump into like specific parts of the code, the diff thing. We've heard from a few folks. So yeah, we're definitely gonna look into implementing it. Yeah.
Cool. All right,
Yeah,
cool. Do you want to show a bit more of the internals and how it works? And now, can you feed data here in real time, right? By the way, one feature request I had, not sure if you, is to auto refresh, like search.
Yeah, that would be good. Yeah, that's a good point. And
It's
then
not
you would be able to
can't,
look at the last like 5 minutes or something
it
like
can't
that.
be that hard, right? It's just literally just a
Oh yeah.
JavaScript function, right? That just calls a set timeout, right? So it's no, your UI is React, right?
Yeah. We use React for the UI stuff.
Yeah. So yeah, because it makes a difference because at the moment, like in a way, you can feed data on this in real time, right? Because you just send data to the listener, right? And it will update this, correct?
Yeah. So like right now, it's almost real time. We chunk it in 10-second chunks and send those 10-second chunks. Actually, I think a lot of other monitoring tools do it kind of similarly, I think.
But when you say you chunk it in 10 seconds, you don't chunk in terms of receiving it, right? It's just you capture the exact timing of what it is. It's just that you're just broadcasting every 10 seconds, right?
Yeah. So so basically we have like the resolution we get is 10 seconds. So within those 10 seconds, we don't know exactly when an event happened.
Okay, that was my question. So you do aggregate them, right, into 10-second intervals, right?
Yeah.
See, that's something you guys need to change, right? Because I feel that, I guess that's why this all is well spaced out, right?
Yeah, exactly.
I think that granularity is going to be a problem, right? So for example, like one of the projects I'm involved in, I actually need to track it. I will actually want to send events, right, to the flame graph. I was actually thinking this is a great way for us to actually debug, right, our solution, right? Because it's basically a Kubernetes application that has multiple nodes, and I actually wanted to use this to track the processing of all the sequence of events. Basically, it's processing a file, so I want to track how long it takes a whole file to do the round trip, right? But for that to happen, I actually need accurate milliseconds, right? Timestamps here, right? It's kind of like you want to do it, so it's almost like you don't want to do it at writing, right? It's okay for you to say, like Elasticsearch does. There's, depending on the view, you end up having a certain degree of consolidation. But I think if you do it on writing, you're destroying data, right? And you kind of don't want to do that. You almost want to save the data as much as you get sent, right? And then based on your whatever view you have, whatever mode you have, then you slice it into specific sets, right?
Yeah, and there are a few ways we could approach that. One way would be to also save specific timestamps along with width of the bars. And the other thing we could do, this 10-second interval is configurable, so we could add some sort of parameter where you could specify a different resolution, maybe 1 second, 100 milliseconds, something like that. Yeah, we could. Yeah, we will definitely look more into it.
Cool.
Yeah. So should we dive a little more into the internals?
Yeah, of course.
All right. So yeah, we prepared a little presentation specifically about the storage engine and how we are able to store data so efficiently. Because we see this as one of the important parts about this whole project. With a lot of other monitoring tools, sooner or later you start to get into this issue where you're storing a lot of data, and now this monitoring tool that's supposed to like help you and help you maybe save money or something, the monitoring tool itself starts consuming a lot of resources. So we really focused a lot on building a scalable storage engine so that you could store a lot of data. And so I guess I'll skip the demo slide. So yeah, so we started with like an ambitious premise. We want to store years of profiling data with this 10-second resolution. And let me just.
So can I go back on that one? See, this is the thing, right? So if you go back there, what you almost want to think about is the model that's, I'm not sure exactly the right name for this, but it's almost a model where you start to refactoring the time based on how far you go back. Do you know what I mean? So the idea would be that you actually start, for the day or the week, you are at millisecond. Then for the next day, the next time slot, for the next month, you actually are at 10 seconds. And then for the next, year, you actually are at a minute, right? It's almost like you can make it configurable because, of course, each of these has a cost. So and again, my recommendation would be that you almost look at, having a specific set of resolution that makes sense, because it's also like the same thing with AWS storage, right? You want to have a mode where you basically, can shift data away, right? But then it's available on demand, right? But again, you don't need to, what I care about the past is almost trends, right? It's almost like specific big topics that I want to compare, but it's still very valuable. And then that almost becomes a business decision where I need to have a 1 second resolution or 10 seconds or a minute or an hour, right? And then of course, because there's a direct correlation between that and cost. And if you want to play the game, which I think you should, of going for breadth, where you're basically saying, look, for a number of systems, you don't need 10 seconds, but you need years of data, right? And I think your model, could probably support that, where it's about, whatever, that's, kind of interval you want to consolidate the data into, right? That you capture. But I do feel that you want to go from milliseconds to 10, seconds or minutes, right? Depends on the business case and the value that you have there, right?
Yeah, that's a good point. We've definitely been thinking about this, basically having some sort of a retention policy where, data that was recorded a month or a year ago or whatever would be stored with less resolution, right? And then, would be more efficiently stored.
Yes.
And I guess we could also go the other way, which we haven't really thought about much, which is, for the last, I don't know, minute, hour or something like that, to store it with even higher resolution, which is what you were talking about
exactly
earlier,
right? And to be fair, you could also have the 2 modes, right? Which is again what I see a lot of more mature, for example, even with Splunk and others, where they have a very wide set of data sets that don't have a lot of resolution, but then have a very good solution that when they say, okay, I want to know what happened on this period, then they load the data in, right? So if you think in terms of cost and storage, you can say, yeah, we do store 10-second resolution, but it goes on Glacier, right? So it's there over there, it gets shipped over. But actually on the more hot storage, we have a minute, 2 minute resolution. And actually in real time, you only see an hour or a day resolution, because at that moment in time, you're just looking for global trends, right? You just want to do that comparison of traffic, but then you want the ability to go in and out, right? Of the resolution, right? Because the other thing I was just saying is that don't view that people will have just one UI for your thing. When I think of your platform, I would want to have 10, 20, 30, whatever, all sorts of different views, depends on what I'm looking at, right? And almost like the data source that I'm consuming will depend, but the concept is always the same. I'm seeing a particular stack trace, a particular sequence of events, right? That is giving me business context and allows me to make either decisions or give me more situation awareness, right? So it's almost like you want to decouple your resolution, right, with the business. So I appreciate you don't want the business case to be affected by the resolution. You want the resolution to be almost tightly coupled with the business case, right? And the irony here is that what you find is that what you might think as a corner business case might add so much value that if you can nail that one, then that's almost a reason to use your technology. That's a reason to send you data and to use our cloud platform, right? But it's very important that business use case is very tied, in this case, to the resolution that you're actually capturing, right?
Yeah, that makes a lot of sense. Yeah, that's a good way to think about it.
Cool.
Yeah, so with that in mind, so first thing I want to kind of talk about briefly is how this data comes in. We use sampling profilers, meaning that they work by looking at the stack trace 100 times a second or something like that. And so for a simple program like the one on the right, where you have fast function, slow function, and then we just call them for a while loop, the stack traces would look like this, where you have fast function work, slow function work. And because there's more work happening in the slow function, you'll have the fast function appear more often than the slow one, or the other way around. The slow function will appear more often than the fast one. And so this is kind of how this data, this is the original format in which the data comes in.
So I had a couple of questions on this. So you, in here, because I looked at a couple of other tracing apps, right? So you're using the same trace format as, is that the one that the Google Chrome and the Profiler uses? Is that the one that they also use?
So there's a few different formats. I've seen pprof. That one is more optimized, and it's I think they use protobuf to serialize all that stuff. And another format that a lot of tools use is something like what I'm showing here, where it just prints like stack traces over time. I don't know if that necessarily answers the question, but this is one of the formats that are used.
So the format here, just very simply, that you have the stack trace is literally just whatever string is, semicolon, string, semicolon, that, right? That's just literally the stack trace. And then for more let's say on .NET or Java or even Python, right, you get the fully qualified name of the class that you're executing in there, right?
Yeah, and those get really big really fast.
Well, I know. Exactly. Especially in Java, man.
Those start, like the example I was showing, this Python one is very simple. Like the stack traces that we see from like real apps, they're always like much deeper.
Well, one of the questions I'm going to ask you later, but is also how can you process them? Because I think there's value in consolidating that. Now on here, where do you store the timestamp?
So that's the thing. So right now we do that 10-second aggregation, right? So I'll talk about it slightly later about like how we store timestamp for those 10-second chunks. But when the data comes in, we do get a timestamp with it. It's just right now we're not really using it.
But you don't capture the timestamp here, right?
Yeah, because of that 10-second aggregation that happens.
Yeah, so
Yeah.
I think you need to add that feature, man. Again, can I add a feature request? Right?
Yeah, I think, yeah, that's very fair. I actually, yeah, we appreciate that a lot. This is a
But
fair
I
point.
also think that you need to add, although you could always cheat a little bit because technically, but I think you need to add the ability to add metadata here, right?
Yeah.
Because I can give you a unique ID, right? So for example, like if I'm generating lots of traces, right, for even across multiple places, right? Like one of the things I would want to do is reduce it almost. You can clean up a little bit, maybe some of the traces on the way in, especially if you control the profiling, right? But you do want you do need a way to keep track of, for example, individual requests, or especially when you hit those parallel sequences, right? You need a way for the original data to give you, right, some kind of metadata, some kind of IDs, even if an ID that you can go somewhere else, but ideally a way to give metadata to your database, right? That that then when you do the correlations, you haven't lost visibility, because at the moment you are losing visibility, right? Quite heavily here, right?
Yeah, you're right. And we, as I kind of mentioned earlier, like we do have that. We're planning to support that in the future. So like this storage engine supports that kind of use case, and we don't have that implemented yet, but that's definitely an important feature. Like then, we could correlate it with traces, with other monitoring tools and things like that.
Yeah. And when I think about security reviews and security assessments, right? For example, like let's say that I'm fuzzing the application, right? And I'm basically sending all sorts of bad data, and I want to almost see what kind of fuzz element, right, is breaking the stuff. So I almost maybe want to mode, and I don't mind if I have to write some extension to the profiler, right? That's okay. That's, again, the cost of that is it's a one-off cost, right? You do one-off cost and go, look, put this profiler and then fuzz over here, right? But you need to be able to correlate, for example, the payload or the hash of the payloads with what happens. Because then what's going to happen is you're going to have 1,000 payloads that are okay, but the 1,001 or the 1,578, right? That's the one that caused a problem. And that's the one that now has a statistical difference, right, in the path, that show me a different path, right? And that's golden, right? That's where it gets very interesting, where you find those vulnerabilities or those blind spots, but you totally need to be able to correlate, right, the individual traces as they fly through.
Yeah, this is great. All right, so let me continue with this. So basically, the first kind of thing we do that's pretty obvious is we group these samples that we're getting, right? Where we get a lot of repetition, we just group them into, groups of samples. And that already helps.
Do you see that on the flame graph, actually?
Say it again?
Do you see that on the flame graph on the weighting?
Yeah. So then later when, when you have I don't have an example for this one, but on the flame graph, you will get one, fast function take 20% of the time, and then slow function take 80% of the time. And so that's like the first kind of obvious optimization we do. Then the other thing we do, and that's where it gets kind of trickier, is we take advantage of the fact that a lot of the symbol names also repeat. So for example, and I think Java would be a great example, where you have all sorts of classes that start with the same thing. So from a namespace or something like that, right? This example is from Go. So for example, when maybe you're making an HTTP request and there's a read and a write happening, in this case, this net thing is a namespace, and so you can take advantage of the fact that they repeat. And the way we do that is we use a trie, or they're also called prefix trees. Basically, instead of storing these strings along with the profiling data tree, we store them in this separate data structure that stores the prefixes just once, right? And so for
is this now using Badger? So is this at Badger level, or is it at the collector level?
So this is at Badger level. Yeah. So this happens at on the server, the database part.
Yeah.
And yeah,
I think it would have been good, because I read a little bit about this, so I already got a bit of a sense. I think you need also a diagram that shows that flow of data, right? That shows the data starting at the request, going to the profiler, right? Then hitting Badger, right? And that kind of flow, right? And then seeing kind of how he goes in and he goes out, right? So we can start to get a better sense of the flow of data, right?
Yeah, you're right. That's a good point. So yeah, this is kind of how the data flows. So we have Pyroscope exec. That's the part that profiles either a Python app or a Ruby app. And we have a separate integration for Go. And they only do this first level of compression, if you will.
So is the 10-second limitation already built into the profiler one?
Yes. Although, like, we could add those, timestamps, like you were saying. That would be, relatively easy to add. And I think, yeah, we're definitely going to look into it. I think that could be a cool, like real-time feature type thing. Yeah.
Yeah, I think when I was reading about X-rays, I think they do something on, you can go from real time to aggregation, depends on the volume, right? So at low volumes, you actually allow and provide real-time collection. But if there's a certain amount of volume, then it starts to sample, right? And I think then is about, I think it was like 10% of the time or whatever, there's almost a sample interval. But again, it's that idea that, but I do feel that, especially for simpler use cases, having that very, very real-time, view of it, which is very millisecond accurate, is actually quite important, right? Because it gives a good sense of, so some of the use cases will kind of need that level of granularity, right? So to even understand the duration, right?
Yeah, that's a good point. And that would also enable us to have other types of visualizations, perhaps with, just more information. Yeah.
Because I think what you're telling me, that you actually tell me that your granularity of duration is 10 seconds, right?
Yeah.
Which then, it doesn't tell me which actually, what is actually misbehaving, right? It's cool at a macro level, but when I want to look at who's misbehaving, right? You probably want to go more granular, right? In some of those cases.
Yeah, that's a great point. Yeah.
Cool. So this is now happening at BadgerDB, right? So in BadgerDB, you already store the data as a graph, right?
Yeah. So when it comes to storing it, so basically we store the symbols separately in this trie, and we store the rest of the the actual like flame graph data separately in separate trees. And I'll talk a bit more about that part in a second.
So do you actually use dgraph at all, or you just use Badger?
We just use Badger, yeah. So we use the kind of, what we use it for is basically storing things on disk. We use it as like a key value storage thing.
Are you compatible with dgraph?
Honestly, I'm not sure. I don't know.
Something. Okay, so I think you should, especially if you be early on, I would definitely recommend you try to be. You know why? Because you then get the GraphQL queries for free.
GraphQL.
Because even if you say that you don't support it natively, or you're on your implementation, right? You don't have for some deployments, you don't have it. If your data store is dgraph compatible, means that I could always consume it from dgraph, right? I could always have, even if it's a read-only, but dgraph will give you GraphQL. dgraph will give you all sorts of visualizations, all sorts of solutions, right, for it.
I see. Yeah, that's a good point. Yeah, we'll definitely look into it some more. That's an interesting use case too.
Cool.
Um,
So you now, yeah, so now you're storing in Badger like name value pairs, right? And again, you're leveraging Badger, yeah, ability and scalability, right? Because Badger scales quite spectacularly.
yeah, yeah. Yeah, Badger has been great so far. And yeah, so what this allows us to do, this try thing, is we can go from storing these long strings to just storing, short zeros and ones. Yeah, and the other part of this puzzle is, just taking advantage of, repetition just in terms of these nodes, right? That's kind of what happens in a flame graph anyway. And so, if you have an example like this where there's request, connection, read, and then request, connection, write, that ends up looking like a tree. And, that obviously also helps with storage.
Yeah.
Yeah, and so yeah, that's kind of the basics. That's how the data gets written. And the next big challenge is reading it efficiently. Because it's fine if if you only want to read kind of like 10 seconds at a time or 1 minute or something like that. But once you go into years, it gets tricky. And so like the simple way to do this would be to just, write these 10-second chunks, one after the other, right? And then later read them and merge them. But again, this doesn't scale very well. So what we do instead is we use these segment trees. So for example, if you need to read a lot of these trees at a time, we do this pre-aggregation where we instead of writing to just these 10-second chunks, we also write into larger 100-second chunks and then 1,000-second chunks. And then later, when we are ready to read this data, instead of reading, a bunch of these, we can read a few and merge them without needing to merge all of the small chunks. And so that turns this linear algorithm into a log n algorithm where, even if you're looking at a 1 year of data, it's still very fast. The queries are still, very,
So,
very,
but in
very.
this case, when you read, the 1 year data will be the bottom yellow, right? Or a combination of
Yeah.
the bottom yellows where maybe that represents a day or a week or something, right?
Uh-huh.
And then when I go, oh, actually, I want 3 months, then that's when you get the next level and a bit of the other, and then you keep going as you zoom in, right?
Yeah, exactly. Yeah. And so yeah, like if
But how does this work then in practice in terms of the data that you store? Because the data is still stored in that graph format, right?
yeah, so that yeah, so each one of these blocks is essentially a tree like this, right? But with obviously a lot more nodes. And yeah, like these trees will usually have less things going on in them. These will be larger with more branches, and these will be even larger. So one thing we also do is, as it gets to like these lower levels, we also start dropping certain leaves that are not very that don't have too much data, right? Like maybe we only have like a few samples for those leaves. So that also helps. And when you look at a year worth of data, it doesn't really affect anything all that much. And we still keep the ability for you to zoom in and still get to see all of those leaves.
Cool.
Yeah. So yeah, so that's it for the storage engine. Yeah.
So
And
how could you run this on, for example, on a Lambda function, or if I want to deploy this on a cloud environment, AWS, what do I need to deploy?
yeah, so right now, I think for Go, it would work pretty easily. You know, for the Go integration, this agent part is part of the process, and so you know it can profile itself. There are some caveats with the Ruby or Python integration, and we're still kind of working on figuring that out. Because right now we have this agent. So right now, like the way it works is there are two processes, right? And anytime anytime it runs in some sort of like a container containerized environment with like high security, that tends to not work super well, because you sometimes like those functions that let you look at the process's memory, they're disabled or something like that. So we're working on improving that.
Actually, on Python, are you what are you using? Are you using that the systrace technology, or are you actually using are you using the OS capability to do systrace, I think, or strace, sorry, at the OS level, or are you actually using Python systrace to capture it?
We're using PiSpy, which is this cool project. The idea is that this profiler is a sampling profiler, and so it doesn't have much of an overhead. That's kind of the biggest selling point. And another cool thing about it is that it looks at the memory of the profile process and reads the stack traces from that. And so, you can connect to an existing process and things like that. So those are kind of the advantages. The disadvantages are that, yeah, on some systems where, security is heightened, like sometimes it doesn't work, or you have to kind of take extra steps to make it work.
Yeah, but that's why you need the CSP trace, right?
Yeah.
Because it's using strace, right? When you're running Docker, right?
So strace, as far as I know, like isn't that only for like system calls?
Yeah, I guess that was the thing I was going to ask. So this actually so this actually reads memory of the program, and then tries to reverse engineer the call trace, right?
Yeah, exactly. So one
I was just gonna say, have you documented how to send the data to your kind of capture?
That's what we're working on.
Yeah.
That's what we're working on right now. We got this request from a lot of people. People just want to push data from like different other profilers, right? And so yeah, we'll soon release something with like a well-documented like how to send the data to the API and things like that.
Yeah, because the Python profiler is quite powerful, right? The Python set profile, you can actually get a huge amount of information and data, right? That's where you actually be quite granular, right? You can then choose, it can be generic, but you can be customized it quite nicely. And that's why I was saying that if you then allow to pass IDs and GUIDs and some metadata, and then the call trace, even if you say you can consolidate or giving a weight, pushing that a little bit to the profile, whoever sends you data, that'll be quite powerful.
Yeah, and also there are a lot of different kinds of profilers for Python with different, again, like pros and cons. So yeah, we're definitely we're seeing this as kind of like an opportunity to have a lot of different profilers all kind of feed data to Pyroscope. That would be really cool. Yeah.
Very cool. Good stuff. So do you have like more like specific use cases or examples that where you really kind of added added crazy value or like those kind of use cases?
Yeah, so far, we haven't been doing this for very long. We released it January 1st. The use cases we've seen that work pretty well are things like, I guess the biggest ones are where people were able to save a lot of money by just like analyzing these trees and finding things that didn't quite make sense. So for example, one company, they found this place in their code where they were using compression, and that compression was taking up 30% of the time, and they didn't know about it. They use other monitoring tools, but they were unaware that compression takes that much time. And turned out that by default, the compression was set to like the maximum level, and that's why it was taking so long. By just lowering it a bit, like by lowering the level of compression, they were able to, get rid of that bottleneck, and that saved like 30% of the runtime of the whole thing. So it's some sort of an app that runs like on, I guess, like 30 servers or something like that. And yeah, they were able to, just remove 10 of them because of that. So that's like pretty cool. Other things we saw, people just, just like kind of learning more about their applications. People were able to find, just like things that it's kind of similar to these, to this compression example, but maybe less important in terms of cost savings and more important for latency. Like people found slow code that, again, they didn't know was slow, or
Well, I
were
guess
able to
what's
optimize.
interesting about this is that if you're profiling an application that calls other services, even if you don't capture the other services, you will see where the slow calls are, right? Like, for example, that socket there that you have, if that's the beginning and the ending, right? Then you can see that the whole thing maybe is what it took, the socket added connection or data to be there, right?
Yeah. So usually, like high level, it gives you ideas of, okay, like, these functions are the ones that take up time, right? And maybe that informs your decision that, oh, I need to like go look more into why this is happening. And also, yeah, sometimes it also helps, kind of like once you figure out that, okay, like this particular request seems like something is wrong with it, what do I do next? Then you can, click on it some, and sometimes get some interesting data from looking at these stack traces. Yeah. I think you're muted right now.
Oh, sorry. Any interesting features that you want to mention last couple of minutes?
Yeah, so one thing that we recently released is the comparison view. Definitely has been useful for comparing things like after you deploy or something like that, or after some sort of an event happened, or if you did have some sort of an outage or strange event, you can zoom in on that and then compare it to the time where things were normal. We definitely see that, like, right now it's pretty hard to analyze with just two flame graphs side by side. We're gonna add a diff soon. Ryan, what else do we have coming out soon?
I was just gonna say, if you go to like the last year on this, you can kind of see a better example of like where you might want to see like, oh, what was going on when things were good versus when things were bad. And so like in that case, there's like logging a bunch, and so some error was preventing things from happening. But we're also working on alerts, kind of like you said, being able to show when when something does deviate from what you expect, being able to add that in and be able to see the difference between them. And yeah, I mean, a lot of what we're doing right now is kind of the stuff that you said of just adding more sort of like of functionality features. So being able to do different time ranges and being able to, add more languages that we support, in addition to eBPF, Ruby, Go, and Python. People have asked for, Java, Node, Rust, a bunch of other languages. And so, so basically just adding all of that stuff. And then, we love helping people set it up. And I mean, that's kind of what we're up to, and would love to talk to, we've got like a small but good community of contributors. And so if anybody and that kind of stuff, we love it. And this feedback is awesome.
Definitely feel that I need to find a good way to just, we use a lot of Lambda functions. We have a lot of, also Jupyter notebooks. So, this will be an interesting one to add to a notebook to see, for example, where is the data being, how efficient is that code? And I was just thinking that, because I think that this is prime for machine learning, right? Because, there's so much interesting stuff on it. But again, you have to be careful not to reinvent the wheel. So I was almost thinking that if you find a way to export the data to Elasticsearch, for example, right? Where again, you can leverage the fact that Elasticsearch already has a lot of machine learning capabilities, right? Because the thing about this is that you are creating a graph, right? So once you have the graph, you can do lots of good queries, lots of analysis from it, right? So there's almost like transformations or meta-analysis that you can do once you have that, right? Because the hard part is almost capturing and getting into that and solving that problem, right? So, and then the more you can solve that problem of how do I go from the raw data to the flame graph to the data that is good for the flame graph, then you can almost want to leverage other parts, so you don't reinvent the wheel, right? If some part of the market has already figured that out, even in the future you might want to have your own, just by, for example, being able to take your data and send it to Elasticsearch or a subset of it, right? Suddenly, it's not that they're a competitor, you're actually leveraging them, right? Because then you can say, look, you can use this and this, but you still have the collector, you still have that way that you're still in the loop, right? And that's kind of where I feel you add a lot of value, especially the more your data is stored in a graph-like format, right? Because that's a highly scalable way of storing, like you're already doing, lots and lots of data.
Yeah.
Makes sense. I was also going to paste the storage design. We added a version of the presentation with some GIFs to, kind of depicting some of the stuff that we talked about. So I just pasted
Dmitry, do you want to just open the app and share your screen so we actually capture it? Because
yeah,
cool.
So that would be here. And it's more or less the same presentation, but it also has these GIFs where it kind of illustrates how how all these things work, and it also shows you like how exactly like how many bytes we're saving on each step.
And look, for example, like that's massive, right? Like if you think about it, like if you get really good at that for example, even compression level at for example the stack trace, right? Then the interesting question is, where do you do it, right? Like where do you do it on the server? Do you do it on the thing? So there's also interesting place you can do, right? I for example really like the idea of persisting sometimes data into JSON and then being able to import it again, right? So you have or a particular format that is almost text based, but it allows you to again store a lot of stuff and then reload it again, right? So you don't need to be live connected to a system, or I always think that I don't want to be creating puppies, right? Like for example, I don't want a system that now the only place where that data exists is over there, right? I want a system that I can send data, but then have it persisted, which again gives you backups, gives all sorts of stuff, right? But that just the optimization that you guys doing here, that is quite massive, right? Because this, and it'd be interesting to get some statistics on this, right? Because when you don't do this, again, like you said, those stock traces get ridiculously, massive, right? Where actually with this, you can then actually store, very effective. In fact, what you might want to also think about is almost, almost doing the same thing even for a particular stack trace, right? So if you have a particular stack trace that almost looks like this, you can already create a one that again, that gets given the value 1. Do you know what I mean? Like, then you can actually, if you have 1,000 requests with this exact same pattern, why doesn't this become another tree, right? Another node in the tree, right? And then you get, because then it's about how the more and more data you want to store, the better, the more relevance you have, right?
Yeah.
Yep.
Yeah. So speaking
really
of,
cool.
we did some benchmarking against just gzipping trees. And I think the numbers we were getting was about like in 10x better. So like doing all this stuff that we're doing results in like about 10x improvements.
Yeah. No, it is the way to do it, man. Because with a graph, right, it's you have so much efficiencies, right, and it's so much better.
Yeah.
That's why I think that if you go to dgraph, I think you'll find that you'll be able to create a visual representation where you also deconstruct it into the dgraph. Because again, GraphQL is a great way to also see it, right? How everything flies together, right?
Yeah.
No, this is really cool.
Yeah.
Good stuff, man. Look, I think well, look, that's you're on our Slack channel, right? So let's do a couple of sessions, start some threads there, and then let's do another session next month where we get maybe try to see if we can do some workshop to actually get people to actually write something and implement it, right? Which again, it's good if you can get some cloud examples, right? Then it becomes easy just for people to maybe think in terms of labs and what would be a good setup, right, for somebody who just maybe generate traffic, right? And then we can start to see it. And actually, you guys support nodes already or no?
Not yet, but yeah, we see a path for that.
Okay.
Oh yeah, maybe soon.
Yeah, well, I'm just thinking that it'd be interesting to pick up maybe a couple of vulnerable web applications, because I think vulnerability it'd be really cool to try to pick up what does the pattern of a vulnerability looks like. I'm really keen to see, like, can we pick up patterns that an authentication blind spot will have? Can you have a pattern that a particular set of vulnerabilities, a particular denial of service, a particular kind of exploit will have? So we can maybe try to profile a couple of vulnerable applications, and then and then seeing how that flies together, right?
Yeah, that would be cool. Yeah.
Cool.
Yeah.
All right, man. So I'll start recording, and I will continue next month.
All right, sounds good.
Thanks.